We're going to start section 1.1, solving equations, and we're going to start out this section looking at some basic terminology of equations. So you have those definitions in the middle of your page, and we'll fill in those blanks together before we look at some examples. The first definition says that a number makes an equation a true statement is called a solution. You can fill in your blank with the word solution, or the root of the equation. So a number that makes an equation a true statement is called a solution or a root of the equation. And then the set of all numbers that satisfy an equation is called the solution set. The solution set. When we're solving equations, we have the addition and multiplication properties of equality, and these properties state that you can add, if you add the same number to both sides or subtract the same number from both sides, then you have not changed that, and that's what we're going to use is the addition and multiplication property of equality to solve these equations. You will also see a note at the bottom of your page that says, for example, if A equals B equals 3 and C equals 4, then 3 plus 4 equals 3 plus 4. Similarly, you see that for multiplication as well. And that's just giving you some real numbers to go along with this property that you have here in your gray box. Alright, so if we'll flip over to the next page, then we're going to go ahead and start our next or our first example. But before we do that, we're going to talk about the steps for solving equations. When you are solving equations, the first thing that you want to do is eliminate fractions or decimals, and we do that by multiplying by a common denominator, or when dealing with decimals we do that by multiplying by 10, 100, or 1,000, and we're going to look at some examples of that in just a second. The second thing that you want to do is your distributive property, so you want to get rid of any parentheses that you have. And then step 3, you want to combine like terms on the same side of the equal sign. Step 4, we're going to isolate the variables on the same side of the equal sign. So that means we're going to get x's on one side and numbers on the other. Then you are going to solve for your variable. So you want to, again, combine those. Once you move them to the other side, you want to combine those like terms again so that you have x's on one side, your number on the other, and then usually your last step, sometimes you have to divide to get that variable all by itself. And then step 6 is to check your answer. You will not be required to check your answer in MyLabs Plus, but it's always a good idea to check your answer when solving equations. That way you know 100% for sure that you have the correct answer. So if we look here at example 1, we have solve 3 times 2x minus 4 equals 7 minus x plus 5. So the first thing that we're going to do is we are going to distribute, because we do not have fractions and we do not have decimals, so that takes us straight to step 2, which is the distributive property. So we're going to multiply our 3 through our parentheses, and then we're also going to take this negative and multiply it through our parentheses. So we get 6x minus 12 equals 7 minus x minus 5. And then again, that takes us to step 3, which is combine like terms on the same side of the equal sign. 6x minus 12 are not like terms, but on the right side we have 7 minus 5, so we want to go ahead and combine those. So we get 6x minus 12 equals 7 minus 5 is 2 minus x. Now we want to isolate the variables on the same side of the equal sign, so we want x's on one side and numbers on the other. So we're going to leave our 6x, and we're going to bring our negative x to the left. And when you do that, when you cross your equal sign, then your sign is going to change. So when we move this negative x over, it's going to become plus x equals, we're going to leave our 2 and bring it down. So since it stayed on the same side, that sign does not change. And then we are going to take our negative 12 and move it to the right, which is going to make it plus 12. Now you can simplify, so 6x plus x is going to give me 7x, and 2x plus 12 is 14. Now you want to solve for that variable. In this case, since you have 7x and that's multiplication, you want to do the opposite of that, which is division. So you're going to divide both sides by 7. Your 7's cancel, and you get x equals 2. Alright, so your solution to example 1 is x equals 2. Now again, you do not have to check these. However, if you want to check them, you would simply take your 2, which is your solution, and plug it back into the original equation. So for this one, that would give us 3, and in parentheses 2 times 2 minus 4 equals 7 minus, in parentheses, 2 plus 5. So that would give us 3 times 4 minus 4 equals 7 minus 7. 4 minus 4 would be 0 times 3, and then 7 minus 7 would also be 0. So 0 does equal 0. So we have checked, and x equals 2 is the correct solution. Alright, now if we look at example 2, you will notice that there are fractions in example 2. So we will start back with our steps. Each time you solve a new equation, you start back with your steps, and step 1 is to eliminate those fractions or decimals. So for example 2, we will have to eliminate those fractions. So the way that you do that is to multiply by the common denominator. So if you look, you have 3, 2, 4, and 3 as your denominators. So your common denominator for example 2 would be 12. So you are going to multiply the entire equation by 12. Alright, keeping in mind that 12 is understood to be over 1, so the easiest thing to do is to take your denominator and divide it into your 12, and whatever your remainder is what you will multiply across the top for that term. So for the first term here, if we say 12 divided by 3, we get 4. So you know that you're going to say 4 times 2x plus 4. And for your second term, if we say 12 divided by 2, that gives you 6. So you know you're going to say 6 times 1. So that's going to give you 6x. Moving to the other side of the equation, if we have 12 divided by 4, that's 3. And 3 times 1 is 3x. Minus 3 will go into 12 4 times, and 4 times 7 is 28. So now, once you have eliminated your fractions, you can solve this equation just like you would any other equation. So that takes us immediately to step 2, which means we're going to use the distributive property. So you're going to multiply the 4 throughout that parentheses, and that's going to give you 8x plus 16 plus 6x equals 3x minus 28. Combine your like terms on the same side of the equal sign. We have 8x plus 6x is 14x plus 16 equals 3x minus 28. Now isolate your variables on the same side of the equal sign. So we're going to move our 3x over to the left and leave our 14x where it is. So 14x will stay positive, and 3x, since it is moving, will become negative 3x. On the right, we'll keep negative 28. And since 16 is going to move to the right, we will have minus 16. Now, go ahead and combine those like terms. So 14x minus 3x is 11x. And negative 28 minus 16 is negative 44. Divide both sides by 11. And your final answer is x equals negative 4. So your solution to example 2 is x equals negative 4. You can also check this one just like we did in example 1. I'm not going to show you that, but I just want you to be aware that you can do that for each of these problems to make sure that your solution is correct. So don't forget with example 2 and with fractions that you want to eliminate those first by multiplying by the common denominator, and once those fractions are gone, then you will complete solving that equation just like you would any other equation. Alright, in example 3, we are going to look at decimals. Alright, so these examples you will notice come from your book on page 89. They're from the exercises. They are not from the example portions of your section. So I just want you to make sure that you are mindful of that. So the next example that we're going to do is from page 89. It's number 28 in your ebook. And it is dealing with decimals. So you will see that it says solve 0.04 times x minus 12 plus 0.06x equals 1.52. So again, your first step in solving equations is to get rid of your decimals. And so the way we do that is if it is one place after the decimal, we multiply times 10. If it's two places after the decimal, we multiply times 100. If it's three places past the decimal, we will multiply times 1,000. You always go by the higher decimal or the highest places after the decimal present. So if you have one that's one place after and one that's two, you'll always go with the 2 and multiply times the 100. So keep that in mind. So on this one, since we have 0.04 and 0.06 and 1.52, we're going to multiply this entire equation times 100. And remember, again, the idea is the same as eliminating fractions, and that is once you eliminate your decimals, then you will work this the exact same way as you would any other equation. Alright, so when we multiply 100 times 0.04, that moves your decimal 2 places to the right. So that makes this 4 times x minus 12. Plus, when you multiply 100 times 0.06, that moves that decimal 2 places to the right as well, giving us 6x. And when we multiply 100 times 1.52, that moves our decimal 2 places again, and that makes that 152. Again, once our decimals are gone, then you can solve this just like you would any other equation. So we would go to our next step, which tells us to distribute. That gives us 4x minus 48 plus 6x equals 152. Combine your like terms on the same side. That's 4x and 6x. So we have 10x minus 48 equals 152. We want to leave our 10x on the left, so that sign is going to stay the same. We want to leave our 152 on the right, so that sign is going to stay the same, but we want to move this negative 48 over, making it plus 48. So now we have 10x equals 200. Divide both sides by 10, and we have x equals 20 as our solution. So again, when you have decimals, you want to get rid of those decimals first, multiplying by either 10, 100, or 1,000, depending on how many places you have after the decimal. So the next example that we're going to do is on page 89, number 33. And it's going to be very similar to the example that we just worked. So if you will notice, we have 0.3, 0.5, negative 0.2, and 0.4. So since all of those decimals are one place after the decimal, then we're going to multiply this entire equation times 10. Alright, so when you multiply 10 times 0.3, you will move that decimal one place over. That will become 3 times x plus 2. Same when you multiply 10 times 0.5, that will become negative 5 times x plus 2 equals, when you multiply it times 0.2, you get negative 2x, and times 0.4, you get negative 4. Again, you will distribute your 3 and your negative 5, so you will get 3x plus 6 minus 5x minus 10 equals negative 2x minus 4. Alright, on the left you have 3x minus 5x, it's negative 2x, and you have 6 minus 10 is negative 4, equals negative 2x minus 4. Again, you want x's on one side and numbers on the other, so we will have negative 2x plus 2x equals negative 4 plus 4. Now be very careful here because this is a special equation, and if you will notice, you have negative 2x plus 2x, and you're going to want to say that that's just 1x, but keep in mind that if it's negative 2 plus 2, that is 0x, so it'll just be 0 equals, and on the right you have negative 4 plus 4, and that will also be 0. So since your x's eliminate and go away, and you have 0 equals 0, then we say this is identity, and we say that solution set is all real numbers. So again, we call this identity, and it's all real numbers is your solution set. So in MyLabs Plus, if you had an equation like this, then you are not finished when you get 0 equals 0. That is not your final answer. Your solution to this problem is all real numbers, just like your solution to the example before this was 20, and so forth and so on. Now, if you got to the end of your equation and you ended up with 0 equals some other number, 0 equals 2, 0 equals 4, then those do not equal, and so you would say that your answer is no solution. But again, your answer would not be 0 equals 2 or 0 equals 4. Your solution would actually be no solution. So again, as a recap, don't forget to get rid of your fractions first and your decimals. Then you want to use the distributive property, combine like terms on the same side of the equal sign, then isolate your variable by getting x's on one side and numbers on the other, then solve for that variable usually by dividing in that last step. And don't forget that you can always check your solutions by plugging them back into the original equation and seeing if the two sides balance and if the two sides are equal. Now you can try exercises 11, 19, 21, and 27 from the ebook. The answers are in the back for these odd problems. You can click on answers to selected exercises in the glossary if you are using your ebook. And that is it for section 1.1.